Okay, so we will start with textual analysis today. This is the topic that I like the most. And but before that, I want to start with some organizational stuff. So as Tatiana mentioned today, there are some changes in the presentation dates. So let me just show you what I mean here. So I already talked with Bjorn to that he'll present the Spacey. It's a textual analysis library. He will do it before the holidays, so you will have more overview on textual analysis libraries before while you're working on your case. And then so we shifted all the other presentations like at least 1 week later, and I hope it's fine with you guys. So we will start with the things that we're supposed to have before the holidays. We start from after holidays, so it will be in 2022. And I just realized in doing that there are many people who just dropped the course, and so that's why there are so many changes. But I hope it's fine with all of you. But please just double check your own time slots and let me know if there is something wrong.
Sorry.
Yeah.
Last question. I get email from you that my presentation date changed to 17th December.
I asked you if you could do that.
I think that said that it will be if we can't, we should answer it.
Mm-hmm. But so it's your presentation, right?
Yes.
Okay. So I don't know if you could do it like on 17th or not. If you could do that, that would be great, because it's a textual analysis topic. But if you cannot, it's fine.
Yeah, I think I could.
Okay, great. Okay, then I will also bring this topic.
And I have some questions about my topics. Should I ask after the class or
yeah, let's talk after the class.
Okay, thank you.
Yeah, great. Good. Yeah, any more questions on the presentations? Okay, cool. Okay. So there's also some change on the 2 classes that we have before the holidays. So we will try to use the full 2 hours classes. So it means that we will start sharp at 10 or 14. And so because we will have more classes before the holidays, I will basically cancel the final class that we have on the February. So I hope it is also fine with you. And we try to stay on Zoom unless the situation changes on COVID. Just for your information, we have 2 guest lectures in Thursday and next Monday. So on Thursday, a former student of ours from JPM will come. I haven't yet see his presentation, so I don't know what he will present. And also Monday, we will have Seven Sadlo from Stuttgarter Versicherung. He's also very active on textual analysis. And so basically, you will see what people doing with textual analysis in asset management industry. Okay, so basically that's the reason we try to have the full 2 hours. So I try to still have at least half of hour to in order to finish the textual analysis materials that I want to teach you, and at the same time we could still have the guest lecturers.
So sorry, so the full 2 hours are all the dates before Christmas, right?
Exactly, just these 2, like Thursday and Monday.
Okay, so we start at 10 o'clock sharp for the next 2.
Exactly, yeah. And today we also probably need to stay until 12. I hope it's also fine with you. Okay. Okay, any questions? No, good. Okay, so then I will now just present some remarks on case one that I just take a look at your solutions during the weekend. Then I will cover the presentations that you had in the last week, and then we will start with textual analysis. So my impression on at least, like, I guess I watched, I reviewed half of your presentation, your solutions, and on average, they were really good. So I'm impressed positively, and that's why I want to congratulate all of you. But it's still not clear for me how much time you spent on this, because for some of them, it was like, it was obvious that you spent a lot of time. And that's why I'm going to ask you with a poll. So how much, so compared to a normal 6 credit points course, how much did you spend? Ideally, I would expect you select this 40%. So because, like, yeah, you have 2 cases, each 40% and 10% or 20% on the presentations that you will make, then it's a normal course. But let's see. I want to know your opinions. So I just launched this poll. Please let me know. Okay. Like 80% is too much. That's that's not a good signal for me. Okay, so yeah.
Is my connection now better? Can you hear me better?
Yeah,
okay.
yes.
Yeah, if I can comment on this one, I actually think that the time you provided for the case was really okay. The main issue was with the data wrangling and figuring out the inconsistencies, like that the quantity units, for example, kilogram piece, that these were actually monetary units, because I think that's something we can figure out on our own with the data, and that we received this information just 1 week earlier. I think this was really the main difficulty, which dents the timeline to the end of the project. But overall, I think it was okay.
Exactly. Like, but this is the first time I ever had a case study from A to Z. So these things happens. Yeah, I appreciate your understanding on this. I'm so sorry for this kind of stuff. But at the end, I mentioned to some people in the last class, I see that you spend a lot of time on that. So at the end, your grade won't be that much dependent on the exact accounting numbers that you will get at the end. Or if you just made some minus plus mistakes or this kind of things, I won't care that much about this stuff. And at the end, I will evaluate your commitment to the case. So if you spent so much time on that, it's obvious from just a first glance of opening your HTML file. Okay, so I can see.
Let me comment. I think from my viewpoint, it's very important that every student within his time limit can contribute something. Yeah, and if cases are such that some students say, it's above my abilities, I don't know where to start. Then you should tell us. Yeah, otherwise you show within your time limit what you can do. Yeah, and I think we all agree that everybody invests a lot of time and effort into this class. Yeah, so you will not be penalized if you stop working, yeah, when the hours are simply over.
Yeah, it's exactly my impression that the students that we have in this class and students who survived 2 cases and the presentations and all the materials that I asked them to watch during the weekend, so they are above average students in our university. And yeah, the least I can do is a better than average case, better than average course grades. So that's at least what I can do for you. Yeah, so I hope not to disappoint you at the end. Yeah, so 60% on average means that, yeah, so I need to, so we will not have more than 2 cases. So the case that I will give you during the holidays will be your final case, and hopefully no more huge time spending on the course for the next year, so you can you will left with some free time for the other courses, and we will have lots of guest lecturers after the holidays, so it will be more relaxed for you, hopefully. Good. So there are just some good things that I found, and I think it's worthwhile sharing with you. And so, for example, the first one is a table of contents. So some people had this kind of beautiful table of contents in the beginning of their HTML file. It's very helpful for someone when it reviews your such a lengthy notebook. So this is something you could easily add, and it will improve the quality of your work. The second thing is something that impressed me, that people start with CSS styling. So there's like, so you just basically, it's like kind of a web design that you present your numbers much more professionally than a normal data frame table. The other thing is that many of you use a lot of graphics, like geographical graphics, interactive plots, and that's also very nice. It's very impressive. Please do it more. One other good thing is that, so I also found that the commenting is very sufficient. So for example, when you define a function, you need to explain what does this function do. And this is also very nice. One point that you could also improve is the naming. So I didn't see many people with the README file. So usually, so for example, when I see such a fuller structure, I have no idea where to start. I only see that there is a project academic data room, which is the same as what I expected. But these screenshots, the other things, also the file name is not what I expected. That's why if you are deviating from what someone expects, you need to have either a README file or you should have a more consistent namings on your files. The second thing is also I didn't see anyone use a validate on the merging. So usually when you do the merging, you need to have this validate argument at the end to make sure that the merging that you're doing is exactly what you expect. So if you are doing one-to-one merge, you need to validate with one-to-one, or if you're doing M to 1 and so on, you need to make sure that your merge is correct. Yeah, that's all I had on the case one. I also asked Deloitte to give me their presentations. They haven't yet done that because they were very busy, but I will share the slide as soon as I will get them. Okay, now let's talk about the presentations that I got during the last week. So the most important thing is the multiprocessing. So this is something that you need. Watch this video. That was a very great, very nice video. But in essence, what you're doing is that at the end, you need to define a function, and this function needs to go to a multiprocess. And so, for example, if you have a function that gets some numbers, instead of having a for loop that get this function, get this number and do the function, so you can just multiprocess it with this TQDM library, which is a very straightforward way of doing that. So you can say, I need a multiprocess or multi-thread kind of thing. And you say, okay, this is a process map. This is a function that I need to be multiprocess. And this is the range of input. And I need 2 CPU units or more. And basically, because I have now 2 workers, instead of 30 seconds, the whole code finished in 15 seconds. So it's just like how the multiprocessing works. Also, a more straightforward of using multiprocessing is a Pandarallel library. When you have a Panda data frame, you can just apply a function to one column very easily. So you just need to import this, initialize it, and then say, instead of a normal apply, you say parallel apply this function on this data frame. And it will be automatically done.
So the reason is just computer processing time or something else?
Exactly. So it's like basically if you have 4 CPU cores, you will do your code 4 times faster, basically. And especially it's very useful in textual analysis. So you usually have millions of documents that you want to process. If you want to start one by one, that will take a lot of time. And if you have, for example, 16 cores of CPU, you will just reduce it by a factor of 16, the processing time. Yeah, and then another presentation that we had was about Facebook Prophet, which is a very nice tool for time series forecasting. If you want to do some time series forecasting based on machine learning, and you don't want to spend a lot of time configuring your own machine learning tool, this is a great tool that you can use. Okay, any questions on the presentations of the last speech? Okay, great. So now we can start with textual analysis. So what we will do, so I will start first why we need natural language processing or NLP. And then we will discuss some text cleaning measures. And then we'll start with the language modeling. And in doing so, I will introduce you with, I'll try to introduce you with 3 useful NLP techniques that we use usually in finance and accounting. So the first one is sentiment analysis. And the second thing is similarity analysis. And if we will have any time in 2022, we will also cover a bit on topic modeling. Yeah, and if you are very interested on this kind of topics, this is the paper by Lockhorn and McDonald. This is the minimum 2 names that you need to know when you're doing textual analysis. So this is a survey of textual analysis in accounting and finance, and you can easily see the range of use of textual analysis in our profession. Yeah. So why we need NLP? So first of all is that we have nowadays huge amount of textual data. So basically you start from social media, that there are many Twitter feeds that are coming every day from CEOs, from journalists, and so on. We have corporate disclosures, and nowadays EDGAR, which is an SEC repository for all these annual reportings and all the filings that the company has. So basically you can see all the filings that the company has and share with the investors in the EDGAR dataset. And this is a massive amount of text that you can use to gain information on them. Also, after the regulation fair disclosure in 2001, I guess, so companies are required to share with all the investors whatever they share with one investor. So basically, if, for example, they have a call with one investor or a hedge fund or anyone, they need to publish it at the same time to the whole market. And this means that we have at the same time lots of all kind of corporate communications with the investors that are all available in textual format, usually transcripted. At the same time, we have a very nice archive of Wall Street Journal's, Financial Times, and many other news agencies. And also at the same time, we have many websites, weblogs, and other textual data that we can use to process informations that we need. And they're usually used for trading stuff, but you can also use it for many other purposes. At the same time, in the recent years, we had an enhancement in the computational power, which enables partly the computational linguists to come up with better modelings of the language. And it's nowadays we can extract lots of more features from the textual data. We can teach the machines to understand our language and tell us parts of the language that we are needed. For example, there are algorithms that just summarize the text for us, or the translation is also one of the improvements in the computational linguistics. So you basically can translate to many languages nowadays. And all in all, it tells us that this is very important for us in such a course to cover NLP and textual analysis. So what we do in this course, we will mainly work with NLTK, so it is Natural Language Toolkit library. And this is the book that you will find in OLED after the course. And so the material of this course is available on this website, so nltk.org book. So you can basically see all the things you can do with this library. And there's also a nice tutorial on Kaggle if you're interested in. But at the same time, we will have a presentation on SPACY. And but I just realized that unfortunately that the students who decided to present Janice is dropping the course. So I hope I can cover Janice a bit at the end of this 2 lectures that we will have. Great. So this is all I had in presentations. So let's start with our notebook. So any questions before this? Okay. So before starting, I just want to say that most of the lectures notes that I have is from these 2 sources. So this is also especially great. This is a researcher in Tilburg University, and this is basically like a workshop on introduction of textual analysis. So I try to use mostly this kind of materials, and I combined it with other things that I had my own. Yeah, so we will start with cleaning of the text. You can see let me first activate my keylogger. So you can see the keys that I press. Okay, yeah. Good. So basically here we start with the cleaning of the text, and then I will introduce you with the NLTK, and then we'll talk about vectorizing of the text. So basically how we start with textual analysis. And then we will have some dictionary analysis, basically the sentiment analysis that I mentioned. And then we will have also something on similarity. So I hope I can finish the whole notebook before the holidays. So if it could be faster, that would be great. But please stop me if you had any questions. These are the things that you need to know for your case study. Okay, so let's start with the cleaning of a text. So a sample text that I need is a 10K filing. So I hope you know Edgar. So Edgar is the SEC website that includes all the company filings. And basically, if you search for a company, you can see all the filings that this company had with the SEC. So, and 10Ks in US, for US companies, 10Ks is their annual report, which includes lots of details about the company. And so the latest 10K that Tesla had was this. I think this is the appendix file, but yeah, basically. So you can see that there, so this is a Tesla Inc. And yeah, this is the appendix file. Let me find the main file. This is the annual report. And you can see that annual reports is very large. and usually it starts from item 1. So item 1 is usually about the business description, and item 1A is about risk factors that some people are interested in. So for example, want to see if, for example, a company has what kind of risks. You should always look at the risk factors. What is very interesting for us is section 7, which is management's discussion and financial condition and results of operations. So this is called also MD&A, so management discussion and analysis. So which is on the view of the management team, what has been done on the company and what's the future prospects of this company. And this usually has a lot of informative text about the company. So that's why I want to get this textual data. So you can easily download it with a web scraper. But I also found a nice library, which is SEC API, that you can just register here and get a free token. You just import this and say, okay, this is the filing URL. Basically, filing URL is here. This is the filing URL. And say, okay, this is the filing URL, and I'm interested in section 7 and in a text format. So you basically get this original text. So I just want to have this original text in order to just get back to it from time to time. But yeah, this is basically what you get here. So this is item 7. There are some line breaks, management discussion, analysis of, you can see it here exactly. So this is basically what we have here.
Sorry, Zazan, this API works only with SEC, or is it a more general command?
As far as I know, it's just for SEC.
Mm-hmm.
But I haven't digged a lot on that. Dominic?
If you indicate how many letters you want to have, does it only take letters or also breaks and stuff into account? If you wanted the first 1,000, for example.
You mean this 500?
Yes. So is it, for example, possible to just have the first, I don't know, 10 lines or?
Yeah, for lines, it's a bit more complicated, but basically it's the whole text. I just don't want to have the whole text here. That's why I just said I want to show you the first 500 characters.
Mm-hmm.
That's why you can see what's going on here, or we can just have 10,000. So this is basically the first 10,000 characters of the text.
Without breaks, yeah. Okay.
Yeah, exactly. Okay, so before we're doing anything with the textual data, we need to clean this. As you see, for example, there are these line breaks here that we don't need, or there are sometimes tabs and so on. So we can use regex, regular expressions to, for example, remove the line breaks. And we say we import the RE, and we say that we need to substitute any line breaks, or in Windows, usually line breaks include /R and any tabs that are there. And for the line breaks, there are usually some dash when there's a line break. We can say that if there is a dash, you also consider just drop that dash with the line break at the same time. So what this regex does for us, you can see that, for example, these ends are not there anymore. And then I say I just don't want the double spacing. For example, the remaining space here, and so on. I say, okay, if there is more than one space next to each other, just convert it to one space. And this is basically the result of this thing. And yeah, so there is no end to regular expressions, and you need to know many of them. So for example, if you want to remove the email addresses, phone numbers, websites, and so on in the text, you need to use the regex that corresponds to that. But there's also a library that you can easily use and say, okay, I just don't want to do them manually. So this clean text library, you could pip install it and say, okay, from clean text, import the clean, and this clean I just defined a function that get a text and clean it in a way that, so fix Unicode, and it converted to ASCII, and it lowercase everything. So for example, this management discussion and so on, it's uppercase, so it will lowercase everything. It will skip all the line breaks. There will be no URL, no email, no phone numbers, no digits, no currency symbol. But this is still false. I also don't want to get rid of all the punctuations, because I need punctuations when I want to convert to sentences. So that's why I keep this false. And basically I just define this function and say, okay, clean text cleaner my text, and this text will be now there. So this numbers that is there is just now replaced with the number tag. It's now easier for me to see where there was a number and so on. So when I want to do some extract featuring of the text, I can see that, for example, there's a number related item or something like that. Yeah, there are also more libraries doing this kind of stuff for you, and it's up to you if you want to use them and how you want to use them. And the nice thing about this text cleaner library is that it supports also German. So basically you can say that it will understand also German language. So it will use its own algorithm to adjust to the languages. Any question on this part? Okay, cool.
So
now,
why do we want to remove the numbers and then have only the word number?
Okay, for example, if you want to see what is the most frequent thing in the text, and if you have, for example, several digits, then there are many digits that are noisy there, and you don't want to see them, and they are not important for you.
So you want to count the number of numbers.
Exactly. So this text cleaning is usually dependent on what you want to do. If you want to, for example, focus on numbers and see what kind of numbers are there, for sure you shouldn't remove numbers. And as for example, now because I still need to convert the text to sentences, I didn't drop the punctuations. So it's up to you what you want to do and what's your use case, basically. Okay, natural language toolkit. You can pip install it, and then you need to import it. This is one of the great toolbox for doing natural language processings, and it consists of lots of mini libraries inside that. So to access that, you need to say NLTK download, and then you say that there is like something open for you, that you can see what kind of things you need to download. So you can say, I want to download everything, like all packages. So I will show you some packages in a way, but this will be gigabytes of information. So usually you don't need to download everything. So you can say just the popular packages. This is something recommended, but you can see at the same time all the packages and these kind of things that you will see. So for example, one thing that is very useful is the punctuations. This will help you with converting to sentences and so on. And there's Snowball that I will show you in a moment. These are the things that you need to know, you need to install, basically. There are some also corpora. So it means that there are some corpus of text. So for example, someone downloaded already the Wikipedia, and it is also in a textual format. So you can, if you want to learn, you can use this available corpora to do some textual analysis on them, and just be a master of textual analysis, basically. Yeah. So how you can do that? You can say, okay, for example, I need to. So you can visually do that, or you can just say, okay, until NLTK download, for example, the punct library. And because I already downloaded it, it will be just true here. So the first thing we need to do is to to break the language, the whole text that we have to the blocks of the natural language. And we call these blocks of language as tokens. So basically, tokens could be sentences, could be words, could be two words together, and I'll just show you. So the most easiest way is to just look at the sentences as language units. So you can say that, okay, I want a sentence tokenizer to tokenize the text that you have to sentences. And it uses basically the punctuations that you have on your text to understand itself what are the sentences. So you can see now, for example, the first sentence is this, and the second sentence is this, and so on. So it basically gives you all the sentences that your document has. And then usually after having the sentences, you usually don't need the punctuations anymore. So you can use a regex to just drop all the punctuations. Now,
basically, the tokenization is breaking up the text into units that the computer can read. So you can ask sentence number 10 or number 11.
Yeah, I just wanted to show the 10 sentences to you, but you can have all the sentences. So basically, it will be the whole text into the sentences. So you can say, I need to see what is the 10th sentence, and this is
Yeah.
Because I just removed the punctuations, I cannot do it anymore. Yeah, basically you can have your sentences, and you can say, okay, the 10th sentence is this. In this number, we recognize total revenue of this number, billion, and so on. So usually you need to, for example, see how many sentences have this feature, for example. It depends at the end on your NLP application. But these are the toolbox that you need to do this stuff. That's why I'm just covering them. But yeah, like here, when we vectorizing the text, in this part, you will see, for example, why we need sentences and why we need the other things. Okay. Let me remove the punctuations now. Another language unit would be unigrams, so basically the words. So you can see each word is a language unit, basically. So item, number, management, discussion, and analysis of financial, and so on. So all of these things, they are called unigrams because they're basically one word. It could be bigrams. So you just import utilities, ngrams, and you can say, I need ngrams of degree 2, which is bigrams. And then you can just show these bigrams. For example, item number. Sometimes these bigrams have a better meaning. So for example, financial condition, it will be much better helpful for your textual analysis than having financial as one word and condition as another word. And that's why sometimes, depending on your applications, you need bigrams or higher ngrams, which is, for example, trigrams, item number management. So discussion and analysis, it's a nice trigram. So sometimes you need trigrams, sometimes you need bigrams, sometimes you need all of them, basically, and see what are the most important things of your text. And yeah, this is the way you created this bigrams, trigrams, and higher ngrams. So basically, the more ngrams you have in your analysis, the better it has. So the more meaningful tokens you have, but at the same time, the generalizability of your model is reduced a lot. So usually, if you just do a textual analysis on word level, it's much more easier than doing it on trigrams, for example.
Yeah, I think let's give an example. As far as I know, and correct me if I'm wrong, some papers look at what percentage of time is spent on talking about financials. Yeah? And then there is on the internet some kind of trigram or bigram list on financial wordings. And then basically you look how how often these trigrams or bigrams are used in the text, and then you
Exactly.
can see whether a CFO or a CEO is focusing on financials or on other stuff.
Exactly. But as I said, so the higher n-gram you have, it's more precise. So if you have if you have a dictionary on trigram level, it's basically each of these trigrams, the chance of these trigrams happening is much lower than just a single words happening there. And that's why it will be more precise at the end. So less noisily kind of analysis. But at the same time, the generalizability of the problem is a problem there. I will show you at the end when we do some textual analysis. So what's, for example, could be the problem. But the concept of n-grams should be clear by now, right?
Yeah, but so all the papers that I know stop at trigrams. Why is nobody using longer things if you say they are more precise?
It's more precise, but it's like if you are searching for 4 grams, for example, like the chance of you have a 4 gram and it's happening in lots of texts is really low.
Mm-hmm.
And that's the reason nobody goes usually beyond trigrams. Yeah. The next concept that is also very important to know is stop words. Stop words are the words that you usually don't add many meaning to your textual analysis purpose. For example, in English language, let me show you what we have. I, me, my, myself, we, our, ours. They are usually things that doesn't add that much meaning, and they are usually in a high frequency in a language. And that's why you usually need to drop these stop words from your text before you're proceeding with your textual analysis, because usually you are not very interested in how many I is used in a text or how many my is used in a text. So they usually are meaningless. You can have it for many languages. For example, for German, you can see aber, alle, allem, allen, and so on. There are usually these words that you need to drop before proceeding to your other stuff, because they're basically meaningless and they are happening a lot in a text. So you need to drop them to just get rid of the noise that you will have at the end.
The list of words is already in the library, so there is no discussion on what list to use.
Exactly. Usually there is there are very standard. So NLTK had its own stop words. Spacey had its own stop words, but they're usually very similar. There are, however, context-specific stop words. So, for example, if you go to Lockron McDonald website, they have stop words for like auditor text or geographical names. So, for example, if you are doing some audit-related textual analysis, you probably need to drop this kind of stop words. There are things that are meaningless in that context. So, like I think they have also for the financial related textual analysis, these are the text stop words that you need. So this is basically very similar to the general stop words that we had. But for example, you can see also currencies. So you can just drop these currency stop words because they're usually meaningless when you're doing a textual analysis in finance context. So yeah, basically stop words are there to say that, yeah, I'm not interested in these kind of words. And it could be like lots of things. So basically you could have a white list and a black list. So basically say, I don't want to focus on this word set, and I want to just focus on this word list. And that's why you need stop words to just drop those things that you don't want to have in your text at the end. So how to just remove the text, the stop words from the text. So you can basically say, I want to have I want to tokenize in the word level. And if these words are not in the stop words, just have them. Otherwise, just drop them. So basically, you can just do this. And now this text is free from the stop words. So you can see, for example, and is a stop word. So you can see item, number, management, and discussion. So this and is not there anymore. And now you can have a better kind of text, and it's ready for textual analysis. Yeah. So I just do this because I want to make sure that the text I have is standard.
So sorry, Zalman, why is a join order used here? So you join basically the two files, your text and the stop word text.
It is a bit more complicated than this. So basically, in the first step, I have this. So from token to token in my text, I see if this token is among the stop words or not.
Okay.
Okay, and then I will have a list of tokens that are not stop words. But if I want to have a text, then I need to join all of them in a text format. So if I want to convert this list to a normal text, I need this join, basically, because otherwise this will give me just a list. And if I put this list here, it will just paste all of them together with a space, and it will create a text for me.
Okay, thanks.
Yeah. Okay. Any question on stop words? Okay. Okay, now another step in order to make the text more general is to reduce the inflectional forms. What we can do there is, so either we stem the words or we limitize the words. And what are these two buzzwords? So by stemming I mean, we could reduce the words to their stem form. So for example, word playing, this ing at the end of playing, we could just remove it and we go back to the stem, which is play. Played ed could be reduced, and again we will have play. And basically with this kind of analysis, we will reduce all the words into their stem forms, and then it's much more easier and more noise-free would be our analysis at the end. So there are many stemmer available in NLTK. So the most famous one of them is Porter stemmer. So you just import the Porter stemmer and say, okay, this is the Porter stemmer, and you can stem any words that you want to have. So for example, functional would be reduced to function. And if you do this for the whole word in your text, then it will be much easier to just aggregate the words that are related to function. So functional, functions, functioned, everything would be just function. So it's much easier to search for function related words.
So Porter stemmer basically gives you the core of every word. It removes lots of different endings.
Exactly. There are some linguists who are created this library for us. So we don't need to just go to the details of the language to see what are the rules of this language.
Okay. But that's only for German and for English?
I will show you the German version. So let me first finish this. So basically, when you can stem everything, you can do this for the whole text. So you can say that stem any unigram in the whole unigram sets of the text, and then it will be like the whole, it will be for your whole text. So item is item, number is number, but management will be reduced to manage. Discussion would be reduced to discuss, and is the same. Analysis would be analysis, because this is the stem of analysis. Financial would be financy, condition would be condit, and so on.
Stem is what we in Germany call Wortstamm, isn't it?
I guess so.
Yeah.
Yeah. Unfortunately, I'm not very good in German textual analysis, but yeah, I guess it is the same. So there's also snowball stemmer, which is also very famous. The good thing is that you will have many more languages supported by this. So German, for example, would be there. So you can just import the snowball stemmer and say, I need the stemmer in German or English, or I guess 12 languages are there. And then you can say, okay, stem the Lehrer, and which will be Lehr. And so this is like the same in other languages.
Excuse me.
Yeah.
In line 40, we already have dropped the stop words. Why do we have them yet? I mean,
No, it's not, because I restart my text here from the original text again.
Okay.
Yeah. So because I need the stop words later, maybe that's the reason I do that. But yeah, basically that's the reason you see and here. Yeah, so the stemming process is basically reducing any word to the stem, but you can also do limitization, and by limitization, it means that you can assume the role that you want to be stemized. So for example, if you want to reduce everything to the word level or the adverb level or adjective level, you can use a limitizer. The most famous limitizer I know is wordnet limitizer. So you can say that, okay, I want to limitize the better, and I want to have an adjective at the end, and it would be good. So better, best, and good, they will all reduce to good. So it will have some meaning context behind that at the end. Or playing, if you want to have the verb version of playing, is play. And for am, you can also reduce it to verb level, which will be be. So I am, you are, and so on. It will be just be. So it is the limitization version. So usually some people want to do some analysis on the adjective level. So that's why they convert everything to adjectives, and then they count for certain adjectives and so on.
Also, isn't there basically a standard cookbook receipt that is most often used by researchers?
I didn't see that much high-level research on this in finance, at least. There are sometimes, so for example, they want to see how narcissistic CEO is. For example, they analyze the language based on some adjectives that they use. And but this is the only paper I know in finance field. But there are some, so for example, this paper is a survey on basically all the textual analysis papers that we have in finance. And you can, with this overview, you will have more idea like what is doable and what's not doable in finance. And all this stemming, limitization and so on, they are just needed to understand this kind of papers. So what's behind those talks that are there in textual analysis literature? Yeah. Any questions on stemming, limitizations? Okay, great.
Excuse me.
Yep.
For this limitization, we should put every words that we want to change. I mean, or it will group the words in a way. Can we do that?
It will be done in a word level, but if you want to apply it to the whole corpus, you need to say that I need the VNL limitize of any X with for example, verb version, and for any X in your text, basically. And this would be your tokens, basically, which is this will be what you need for the whole text. You say, I want to lematize any X in the tokens that are available in this text. And then it will give you the whole thing. I hope I did it right. Yeah.
Thank you.
Yeah. Now it is sentence tokenizer. I need word tokenizer, I guess. Yeah. And you can join them to have like a whole text at the end. Any question? I hope everything is clear for you. Okay, but there, I agree. There are lots of terminologies that you need to know before we get into any textual analysis. And I think this notebook is a good resource for you in the future. You can just come back to it and check everything what is there. Okay, now we can start with textual analysis, and textual analysis means that the computer can understand our language, and computers don't understand words, but they understand numbers, and that's why the whole idea of textual analysis is to convert any text data that we have to some numbers. And basically, the most useful way of doing that is called back of words approach. By back of words, I mean you have a text here, and then you just convert it to tokens, and you can just convert these tokens to a vector of counts. Basically, here you can say this text here will be converted to it is there 6 times, I will be 5 times, there is 4 times there, and so on. And this is the most simplest textual analysis you can do. So you can basically convert a text to a vector of count. And to do that, we need a counter library, which is like, it's coming from the collection library, and we just import the counter. And what it will do for us, we say that, for example, we have the set of unigrams, and we need to see like the most common 15 words in this unigram. So for example, as you see here in the file that we have, there are 676 times there, which is already a stop word. Number would be there for 654 times, and, of, to, in, and so on. And they are the most frequent 15 words in our corpus. And then you can just, this is basically already what we call a term frequency matrix. So this TF, so we just can convert it to a Panda data frame, but this is basically the most common, for example, 1000 words there. And you can, so we can say basically you can just create the Panda data frame with the term and frequencies, and this is already your TF matrix. There is a rule that basically all languages obey, and it is Zipf's law. And this is basically, if you look at any language and you just rank the most frequent words and go down, there is a linear negative relationship between the rank of this word and the frequency of that. For example, here you can see that the first ranked is there, and this is the most frequent one. The second less frequent is number, which is rank 2, and so on. Basically, this is true for any language. So this is 30 languages that we have in Wikipedia, and this is based on all the text of Wikipedia in these 30 languages. And you can see all of them basically follow this rule, that when you plot the rank of the words versus the frequency, there's just this nicely linear form there. And if we want to see it in our own text that we have here. I just want to use the rank and frequency of this data frame that we have here. We can just also plot this. Yeah, this is also true. Although this is not, it's just one file. So basically it will be true for like the whole corpus of English language, but it still holds for our simple text that we have here. So this is magnificent. Yeah, this is what we call zip flaw. So this is a rule of thumb to see if the textual data that you have has a meaningful meaning behind that. If this doesn't hold, it means that your text data is something randomly generated or something. Yeah, so after term frequency, we have another concept called document frequency. And it means that, for example, if you have many documents, so you count on how many of these documents this specific word is there. So the stop words, for example, there is always in any document. So basically, like all the English language documents, you will find a there. But for example, the word professor is not very like ubiquitous in any documents. That's why there's another concept called document frequency, and we usually adjust the term frequency with the document frequency to make sure that we are selecting the important words and not just some stop words in our analysis. So before doing that, I just want to introduce you with the document term matrix, which is basically if you have many documents. In our setting here, we don't have many documents. We have just one document, but we have it on the sentence level. Okay, so we can call it sentence term matrices, which is like each sentence in a row and all the terms that we have in the columns of this matrix. We can, let me just show you first. So basically, we have now a document of 383 rows, which is basically this 300 sentences that we have here. It could be several documents, but I just have it now at sentence level. So, and you see in total, we have 1,500 words in the whole text that we have there, okay? And this DTM matrix is like basically the count of each of these terms in any of these sentences, okay? So for example, if you want to see the columns, so these columns are, for example, basically all the terms that we have. This 0A is a term, ability, able, and so on until ZEVS. I don't know what does it mean, but basically all the unigrams that exists in this whole corpus that we have are 1,500, and these are basically the columns of this matrix. Okay.
Sorry, I don't yet understand. So the document term matrix is a matrix that exists for one single document, yeah, and the rows are basically all the different words.
No. Okay. So if you usually when you do textual analysis, you have a corpus, and this corpus is like the universe of all the text that you have. Okay, so for example, if you have a corpus of 10 documents, each document will be in one of the lines in this DTM matrix.
Oh, I see. Okay.
In this specific case that we have here, we don't have many documents, but we have many sentences. So we do our analysis on sentence level, not document level. But still, each row represents one sentence in our corpus. And basically, we can see in the first sentence, there is zero count of zeros A, 0 count of ability, 0 count of able, and so on. Okay, but if you sum one row, it will be the length of that sentence, basically. And if you sum one column, it will be the total frequency of that term.
Mhm. And we apply it sentence by sentence, but usually we apply it document by document.
Yeah, usually document by document, but depends on your analysis of that. Yeah. Is
Okay.
DTM clear now?
So sorry, and the numbers are basically natural numbers. Yeah, 0, 1, 2, 3.
They are integers, yeah.
The word appears in the.
Exactly. Yeah, exactly. So it starts from 0, but if there's like, for example, in the first sentence, we have 10 times ability, it will be 10 here. Okay. Now we get back to this TF-IDF measure that I just told you. So we have total, so we have term frequency as we had here. So for example, there has a total frequency of 676. And this term frequency, we can adjust it with document frequency. So basically, if a word is there for every document, so n is the number of sentences, for example, here what we have. If a word is appearing basically in all the big N number, then this logarithm will be near 1, which is really 0. So that's why this frequency will be multiplied by a number near 0. And that's why the weight of this term would be reduced. So for example, for the word D, because this will be near 1, this logarithm of 1 is 0. So 0 multiplied by 600 times of D is still something near 0. So that's why the word D would not appear in the top TF-IDF.
Okay. So this is one way to measure the relative frequency of one word in a document.
Exactly. So with TF-IDF, you basically, this is one way to reduce the stop words in your analysis. So if you want to just focus on the most frequent words, but the important words, you need to use TF-IDF ranking instead of TF ranking. So if you look here, the TF ranking, it will give you the day, number, and so on. And your analysis would be biased toward the words that are not important. But for example, when you're looking at Tesla management discussions, for example, the word sustainable is very important, but it appears only once. And that's why you need to improve the rank of this word to see it in your analysis rather than, for example, the word day or the word number and so on. And the way to do that, so for example, sustainable is appearing only once. So the document frequency, so there's probably just one sentence having that. So you have this big N is 600 and your document frequency is 1. And basically, so it will be 1 plus 1, which is 2, and its big N is around 400. So you have a logarithm of 200 here, which is 2.3 multiplied by term frequency of sustainable is 1, and multiplied by 1 means that instead of 1, we will see 2.3. So we basically push the word sustainable upward in our analysis. Okay. And at the same time, I said, for example, the word there is 676 times frequency. So this 676 is this TF number, but assume that it appears on all the documents. Okay. So if it appears on all documents, so this DF would be equal to N. So this logarithm would be around 1. So logarithm of 1 is 0, 0 multiplied by whatever is 0. So basically, we lower the rank of the word day, like the word day. Yeah, Dominic.
Dominic has has raised the hand all the time. Dominic, you may just lower your hand, because otherwise it's...
Oh, sorry. Thanks for pointing it out.
Okay, so just in one sentence, basically this is an algorithm that basically makes those words more important or have a greater measure that do not appear in all the documents. Yes?
Exactly. Exactly. So there are like just certain sentences that use this word. So that's maybe an important word, and that's why we need to improve the rank of this word in our analysis.
Mm.
So I have just a picture for you. So if, for example, there's a common word, or if you have a stop words, they have a very low TF-IDF rank. Although they have a high TF, but their high DF means that they will get a very low TF-IDF at the end. If you have less frequent terms, they usually earn a higher TF-IDF. If, for example, the word car appeared 2 or 3 times in the whole document, but in several sentences, not just one sentence, but in several sentences, we have 3 car, it means that it's an important word and it will be improved by ranking.
Yeah. But so what's the first point at all why we use this? We want to compare and analyze documents, and basically we focus on the most important words, and then the question is, which are these lists of important words that we compare? No?
Exactly.
And this is one trick to make the list a little more meaningful. Yeah,
exactly.
We could simply look for the most often used words, yeah? except of course for stop words, which we will move up front.
Yeah.
But then the idea is the differences between the documents are the most important things.
Exactly.
For analysis.
The issue with textual analysis is that so the language has millions of words. And if you have a model on language, which includes 1 million inputs, it's usually out of computational scope for many users, and are usually very, very noisy. So for example, you cannot have a regression on 1 million words. If your document term matrix has a rank of 1 million, so it is like 1 million columns in your DTM matrix, it's impossible to do any calculation. That's why we usually try to reduce this big 1 million matrix to just 1,000 most important words. And that's one way to reduce this. So to just focus on the most important words in our analysis. And I hope it's now clearer.
I'm sorry, I have a question.
Mm-hmm.
Yeah, so my question is about the German language analysis. So in German, there are some words that can be divided into 2 parts, like absagen, aufhören. So how should we deal with them if I want to know the frequency of, for example, absagen? Because yeah, it could be like ich gehe dich There are 2 parts in the sentence. I mean, so.
Yeah, I haven't done any textual analysis in German yet. Once I did it, but the problem is, I guess, the stemming and the lemmatization should be very helpful here. So basically, if you just lemmatize everything on a word level, or in a noun level or a verb level, and then you do your TF-IDF, I guess it would be helpful.
Yeah.
That's just my first guess, but yeah, I never did it in German.
Yeah. Okay, thank you. I think maybe, for example, like umgehen, maybe there should be some word like Umgang or something like that. Yeah, it
could be, or there should be
limitation. I mean,
by lemmatization, there could be that there is like another word that represent all the meanings of umgehen. And so the other similar words should be reduced also to this level.
Yeah.
That's why I mentioned lemmatization.
Yeah, thank you.
Yeah. Basically, I lost one interview basically because I didn't know how to do it in German. Yeah, but this is important. I'm sorry, I'm not very good in German.
I think we should note that most textual analysis is really done in English, and most advanced libraries exist there. And for other languages, these computer code sometimes work, but quite often perform much worse, because they need to be adapted.
Exactly. Yeah. So I always translate texts. So there are some APIs to translate to English, and then I do my textual analysis. Especially because for my own language, Persian, it's like there's it's very difficult to apply all of these things. So that's why whatever I get, I just translate it basically, and then do my textual analysis on them. But yeah, probably there are some good ways of doing that in German, especially I guess our guest lectures on Monday. I guess he should know how to do German textual analysis. Please ask him. Okay. So basically, I forgot to introduce you with the sklearn library. So the sklearn. So there is there is a sub feature of that which is called feature extraction of the text, and there is a module cont vectorizer. So basically, it will convert the text to a DTM as we have here, and so we just imported the cont vectorizer, and then we fit the cont vectorizer with our sentences, and that's why we can create the DTM. This is the same if we want to translate to TF-IDF. So there's a TF-IDF vectorizer, which you basically can just import it and say, okay, I want the TF-IDF. You can do it also very simple like this. But you can say, for example, I am interested in higher n-grams. For example, I need a 2 grams and so on. And it will produce this TF-IDF. It will do the TF-IDF calculation for you. And this vector as a fit transform will do the TF-IDF calculation. And the rest of the code is just to show it how nicely. So I just want to show you the top 20 TF-IDF force, which is year, revenue, energy, or I don't know why it's there, sales from December and so on. So they're like, instead of their number and so on, we get into year, revenue, energy, which are much more meaningful words in our context. So you can say, as I said, you can just go to higher in grams. You say, I want, for example, 2 grams, bigrams and 3 grams. You can say, okay, number. So if there are 2 numbers together, December number, number million, the year ended, and so on. They are the most meaningful trigrams in this Tesla annual report. But usually you can say, for example, I'm interested from the unigrams until 3 grams, and then you can see the most important terms. Okay. So basically, when you get a text, you clean it for natural things like line breaks and so on. You create your sentences or your bigrams or n-grams, and you remove the stop words. You do the stemmings, or if you want to, you can do Limitization, and then you basically do a TF-IDF analysis. Sometimes you don't need the IDFs, you just maybe just a TF is enough for you. But then you select the most important terms that you want, and then you create your term document matrix there, or you start doing the textual analysis by counting the words in your dictionaries, in your documents, and so on. Okay, so there are the natural steps that you need to follow before you start analyzing. Okay. Okay, very good. Now, we are interested to say, for example, we extract some features from the text. So what is mostly done in finance is just a back and forth dictionary analysis. So basically, We have a dictionary of positive words and negative words. And then we basically count them on our text. So, for example, assume that this positive and negative word lists are there. Great, good, improve, profit. And negative is loss, negative, and risk, basically. And then you can say, okay, I want to see how many positive words are there. So for any term in the positive, you see how many occurrences happens in the text with this term, and then you just add it to the frequency. And you can do that and see, for example, there are 23 positive words and 21 negative words according to our definition. And you can see at the end also how many words in total you have. You can see, for example, yeah, I have in total 16,000 words. And then you can calculate a measure of tone or sentiment or whatever. So you say, okay, I want to see how many positive minus negative. So basically, I want to see how positive the whole text is. So positive minus negatives divided by the total words. And I just multiply by 100 to just give you a percentage number. So I can say that, yeah, this Tesla MDA this year is 1% positive. And this is the easy part, basically, just counting the terms that you know.
Sorry, Sasan.
Yeah.
Since you already multiplied by 100, it wouldn't be a 1% positive. It would be
1 percentage point.
Yeah.
Yeah, thanks. Yeah. But basically, at the end, you need to compare this. So you can say, okay, for example, Tesla is more positive than Apple, and so on. As I said, this is the easiest part. So you basically count the words that you know they are positive or they are negative. But the most important thing is to define what is the positive word list and what is the negative word list. Okay, and that's why linguists are there to help you. The most famous one is Harvard General Inquiry word list. So they have a website and they explain how they created all this word lists. So there are like hundreds of word lists, I guess. So positive, negative, yeah, these are there. Strong words, weak words, pleasure, pain. So for example, if you want to see how painful they're talking about, you can basically see the word list that, for example, signaling the virtue. For example, economic related word list, militarily matters. So for example, you want to see how militarily related the Tesla is. Basically, you can just open each of these dictionaries and you can see, for example, air is related, ambush is related, ammunition, arm, army, arrow, and so on. There are the related words that linguists decided to apply to this word list. And there are many of them. So basically, for any kind of feeling that you can imagine, there is a word list. How you can get this word list? There is a CSV file, or I think there's a TXT file that includes all the word lists of the Harvard dictionary. So I guess it's there. So basically, for all the positive, negative, PSDF, LDF. So this is basically the things that I just introduced you here. So this kind of word list. There's a column, and you can see. Let me just beautiful it for you. So let's just download this. And now you can see, for example, so for example, for the negative list, you can see the abandon is negative, abandonment is negative, abate is negative. And if it is not negative, it's non-available. Okay, so
now we are just looking at your top right corner of your screen, not the entire screen.
What do you mean? You don't see my mouse now?
I see the entire screen.
Okay, so maybe it's just me. Sorry, it's just me.
Yeah. Yeah. So for example, if you're interested in the positive words here, we just need to get this column and get rid of the non-availables, right? So we say, okay, for the positive, if it is available, we look at the entry, which is like the word level, okay? And then because they are like all capital words, we just want to lower them. So you can see all the positive words here are abide, ability, able, abound, and so on. And there are many of them. We can look at, just want to have the first 10. So you can see abide, able, abound, absolve, and doorman, and so on. And now we can easily do the same analysis that I had on the Harvard word list instead of my word list.
Razan, short question. Is the Harvard dictionary also suited for the financial context? Because
I will come to it.
Oh, okay.
Yeah, I'll come to it in the next cell. So basically now we can see, for example, the frequency of the positive words divided by total words, like the sentiment you get here based on the Harvard dictionary. So the positive sentiment. You can get the negative sentiment, and you can create a tone variable as we had here, positive minus negatives, and it's up to you, okay? But as just Philip mentioned, these words are not necessarily positive or negative in financial context. And this is this famous paper. So this is the paper you must know. When is a liability not a liability? And that's basically, liability is a negative word, but in the context of finance, liability is just a balance sheet item. And that's why it's not a negative necessarily. And that's why Tim Loughran and Bill McDonald, they hand selected all these positive and negative words, and they decided manually if it is positive or negative in the financial context. And that's why this is one of the mostly used dictionaries in finance and accounting. And basically, you can. This is the link to the paper. If I remember correctly, what they did basically, they had the universe of all the 10Ks, like all the annual reports of the US companies. And they did this TF-IDF analysis, and they looked at the most important words based on their TF-IDF, and then manually try to categorize these words as positive, negative, or uncertain words. So this, so I just downloaded. So you can look at their dictionary here. So basically, they have list of their dictionaries. They call this master dictionary in the CSV format or the XLS format. But because it's in the Google Drive, you cannot easily download that. So that's why I downloaded into my Dropbox, and I just read it from my Dropbox. This is basically their approach. So for any word that you see here, they categorize it as a negative or positive, or if it is uncertain word, or it is a litigious word, if it is strong modal or weak modal, if it is a complex word, and so on. So for example, in accounting, people are very interested in complexity of the language. So if a company has a very complex kind of language, maybe there is something wrong with them. Yeah, usually you need to write it in a simple, plain language, English. And if you use certain words, it means that you just want to not explain a lot. Basically, I can do the same here. So I want, for example, the negative word list here. So I can look at the words that their negative column is not 0. And then I just want to lowercase them. Basically, these are the negative words in Lockrand-McDonald dictionary. Yes, Tatiana.
Yes, I have a question. For example, there are negations in the sentence. For example, does not, or don't. And the meaning of the word changes to the opposite. And how do we treat that? So,
yeah, very good question. The thing is, so Lockrand-McDonald, they have another paper in 2016, and they say that they show that in financial context, this doesn't affect a lot. So in a financial context, you can assume that this negative word list already absorb what you mean. So they usually don't say it is not a great year. So it's usually say it's a bad year. And so that's why in the financial context, usually it's safe to use only the negative word list here. Also, in the same paper, they show that you don't need the positive word list because positive word list is usually not used that frequent in the financial context. So you can basically look at only the negative language and compare the components together based on the negativity. Yeah, but that was a great question.
thanks.
Any more questions? Yeah, now I just want to do a little advertisement for myself. So Lockrand-McDonald, so they just introduced their dictionaries in 2011, and since then we have lots of word lists that are available to researchers in finance. So for example, what we have with colleagues, I guess I showed you this paper before. So basically if you want to, for example, measure non-answers. So for example, if I ask you, what is your earnings next year? And you say, the weather is really nice. It means that you don't want to answer. And so basically we have a set of trigrams that allows us to measure non-answers in an answer. And these trigrams, so you can easily download them, for example, here from this link. I already have the code here. So you can see, for example, back to you. For example, you say, what's the matter here? And say, I will get back to you in a moment. Or say, I'm not sure I understood you correctly. Or if say, it's early to tell this, or I'm going to let the others answer this. There are nice ways of not answering the questions, and that's basically what we have in this dictionary. You can, for example, get this dictionary and do your analysis on your own text. Or, for example, the other paper that we have recently, for example, we measured the ESG basically on the startups white papers. So, for example, you can just download this list and see, for example, the environmental list. So, for example, the fossil fuel, greenhouse gas emissions, fossil, greenhouse gas, renewable energy. They are like environmental related words, for example. And if you want to see, for example, how much environmentally related is Tesla, you can see, for example, just count these words in this dictionary as we had before. We see, for example, yeah, this is like 2% environmental sentiment of this text. Okay, but there are like many dictionaries. Yeah.
So these dictionaries are usually the outcome or side product of research. How do you find out whether researchers publish this word lists on the internet? Sometimes it's quoted in the paper, but if it's not quoted in the paper, where do you find out?
Usually, like if you introduce a word list yourself, you are interested in other people using that. So that's why you usually make it easy for people to use that word list. So for example, what we have, for example, for this ESG, we have like a GitHub page that this is how we created this word list. This is, for example, the way you can use this word list.
Mm-hmm.
Some others, so for example, there was a paper, they had like lists of thousands of regular expressions that you need to have if you want to search for this term, for example. So they usually provide the code for that. For example, Locker and McDonald, they just uploaded the dictionary in their website. For example, you can just get this CSV file and do. It's usually straightforward. So as I said, this difficult part is creating these dictionaries.
Yeah.
Using them is like very easy.
But so if you think a word list should exist somewhere, but you don't know where and who did it, do you simply Google word lists?
Yeah, I look at Google Scholar and see the citations first, and then I decide if it is reliable enough or not.
Yeah.
For example, for this ESG related, because it's a hot topic nowadays, there are like millions of ESG related word lists. And yeah, basically like everyone claims that their own word list is the best, and but there's like no one knows what is the best. So that's why everyone creates its own word list and try to work with the ESG score himself or herself. Yeah. So if there is no more questions, I can do the textual similarity next time. Yeah, it will be too much for this session. So I think we already covered it very good. So I didn't expect that much progress. I hope you understood it all well. If not, please let me know in the Piazza forum. Maybe I can provide you with some homeworks if you're interested to do more textual analysis. So yeah, you will be more warmed up before your case, but at the end, your case study will include all of this stuff. So you will, your hands will get dirty enough, and you will be, yeah, an expert in textual analysis by the end of this semester. Also, after this class, I'm going to upload 4 more presentations on EDA. So if you want to do EDA, explanatory data analysis, there are some tools that do this automatically for you and give you a report on the data quality just with one click. And these are great tools that I'm just, your classmates already created the videos. I will upload them after the class with this class video. And then you need to watch them before Thursday. And we will discuss it more if you have some questions there. There's some text in the chat. So do we have to solve the case study during the Christmas holidays? Up to you. So I mean, it's just in my opinion, it's just 1 week of work. So if you all agree, I can just give it to you in the 3rd or 4th of January, and you have time until 17. If you want, I can introduce you as a Christmas gift. It's up to you. Just I will put in Piazza, I will put a poll in Piazza, and I will ask you what's your preference for when you will get the case. Up to you, because at the end it's just 1 week of work, I guess, 1 week of hard work, I would say. But yeah, if you want more time, it's up to you. But I usually think the later you get the case, the better it is, because everyone have less time. You won't be super perfectionist at the end, and yeah, you can at the same time enjoy the holidays. But up to you. I will do a poll after the class. Yeah, great. If no questions, thank you very much, and see you on Thursday.
Thank you. Bye.
Thank you. Bye.
Bye.